G'day boys, looking through our third worked example, solving linear equations. Make sure you familiarise yourself with the slide that refers to opposite operations. So for where you would add something, you would need to subtract something. Where you multiply something, you would need to divide something, and vice versa. Where you would use a power of 2 or squaring a number, you would need to use the square root symbol. The second part of that slide also talks about the order of operations. So familiarise yourself again with BEDMaths. This should be something that is known to you, but just for those of you who haven't got to that slide yet, make sure you go through that. B for brackets, E exponents, D division, M for multiplication, A for addition, S for subtraction is your order of operations, and we use the BEDMaths term to remember that order. Okay, looking at the first worked example, so that you can see on the screen, I'm just going to turn the pen on. We have x plus 6 equals 15. So in this particular example, we're going to do the opposite to add 6, which will be to minus 6. So I'll just put that in brackets to the side on both sides, because whatever we do to one side, we're going to do to the other. So that will leave me with x equals 15 minus 6, which will be 9. Okay. Example number 2, I've got minus 6 this time, so the opposite to that will be to add 6. Again, what I do to one side, I do to both sides. So that will leave me with m equals 1 plus 6, which will be 7. Now, a good way to check as you're going is to substitute your final solution back into the original equation and make sure that that original equation is true. So in the first one, for instance, we've got 9 plus 6 equals 15, so that's true. All right, in our second example, we have m minus 6, so that would be 7 minus 6 equals 1. Again, those two examples are true. Looking at example number 3, we have 7x equals 14. So here we have 7 times x. So we're going to have to do the opposite to a multiplication. So in this instance, we're going to do 7x divided by 7. We're also going to do 14 divided by 7. So I'm just going to put in brackets again the step that we're doing. So we're dividing both sides by 7. So in this particular instance, I can, sorry, I just lost my pen. The two 7s will cancel each other out. Leaving me with x on one side, and 14 divided by 7 will equal 2. Worked example, and again, if you substitute that value in, so 7 times 2 equals 14, worked example 3 is now true as well. Example 4, we have m divided by minus 2. So again, I'm going to do the opposite to a division of minus 2, which will be multiplying by minus 2, close brackets. And we're going to multiply by minus 2 on this side as well. That will allow me to cancel out the minus 2, leaving me with m equal to minus 7 times minus 2. Now we've got two negative numbers, so 2 7s are 14, and two negative numbers will be a positive, so m will equal 14. Again, if we double check, 14 divided by minus 2, 14 divided by 2 is 7, but because 1 is positive and 1 is negative, we'll have a negative result, which will be negative 7. So our solution to example 4 is also true now. Example number 5. So here we have x plus 2 divided by 5 equals 2. So we're going to multiply by 5 as the first step and get rid of the denominator. So I'm just going to write this one out because I'll demonstrate an extra step that haven't previously been in the others. So when multiplying by 5, this allows us to get rid of the denominator, leaving us with x plus 2 equal to 2 times 5, which is 10. Opposite to add 2 is subtract 2, so that'll leave me with x and subtracting 2 on the right side is 10 minus 2, which will be 8. And if I go through and check my answers now, so 8 plus 2 is 10, divided by 5 equals positive 2, making that statement true as well. Work the example 6. Okay, this one's got a few steps, so just bear with me as we work through this one. Our first option, we could get rid of the 2. So what I could do here is make this equation over 2. So that's my first step. I've divided by 2 on both sides, as previously mentioned. All right, so that will leave me with g minus 7 equal to 1 over 2. All right, and that's it because I can cross out the 2's now on that left side. Now, our next step, we've got minus 7, so we're going to add 7. Now, here it's important to remember ultimately we'll need a common denominator. So g minus 7 will allow me to eliminate, adding 7 will allow me to eliminate the 7, leaving me with just g. But that means on the right side where we have a half, we're now adding fractions. So we've got to think back to term 1 where we did addition and subtraction of fractions. Okay, so we're going to have 7 over 1. Common denominator needs to be applied here. All right, so we have a denominator of 2 and a denominator of 1. Easiest option is to get a denominator of 2. So we can leave a half and we can now make this 14 over 2 equal to g. That'll be 15 over 2, which will be 7.5 equals g. Example 7, k over 3 plus 4 equals minus 3. So the first step here will get rid of the addition of the 4. So opposite to add 4 is subtract 4. I'm just going to put that in brackets to the side and put that on the other side as well. Do to one side or do to both sides. This will leave me with k over 3 equal to minus 3 minus 4, which will be minus 7. Okay, now from here what we can do is we can do the opposite to division of 3, which will be multiplied by 3, leaving me with k, allowing me to cancel the 3 out. And then, as I said to you before, we'll multiply by 3 on both sides. So we'll write in the step that we're doing. Minus 7 times 3 will be minus 21. Now, in order to check that this is correct, minus 21 divided by 3 equals minus 7 plus 4 equals minus 3. We know that this equation is now true. Final example, example 8. We have 3 in brackets x plus 2 divided by 4 equals 2. So in this particular example, we're going to get rid of the 4 first. Okay, so I'm going to times by 4 on this side. That'll allow me to cancel the 4 out. I'm going to times by 4 on this side. So what does that leave me with? That leaves me with 3x plus 2 equals 4 times 2, which is 8. And I need my brackets back in there. So from our previous work, we know that we can expand the brackets at this point in time. So I'm just going to draw my arrows in that tell me what to do. So that'll be 3 times x, so that'll be 3x written with algebraic convention, plus 3 times 2, which is 6, is equal to 8. Now it's a little bit easier for us to see what we need to do. So I can subtract by 6 to isolate the variable. That'll leave me with 3x, and remember I've got to do the same on both sides. So 8 minus 6 equals 2. Final step, opposite to 3 times x is divide by 3. That'll leave me with x and 2 divided by 3. And the step I did there was divide by 3. Now, algebraic convention allows us to leave things as a fraction, so we'll leave our final solution here at 2 over 3. So x is equal to 2 over 3.